In problem 2, we're looking at a steady state continuous process. We're bringing in 30 kilograms of cookies that are 19% fat, which means 81% whatever else. And ice cream, we don't know the flow rate of that. We're going to figure that out through the course of solving this problem. It's 11% fat and 89% whatever else. And our goal is to make an ice cream sandwich that is 15 weight percent fat. Okay? And so that amount will be P in kilograms per hour. What I asked you to do in this one is to figure out the degrees of freedom table. So first thing that you do is you identify what streams are you talking about that are coming in and out of the identified process. So our process is this magic machine that I called it here. And so we have cookies, we have ice cream, and then we have the ice cream sandwiches. Okay, so 3 streams that we're talking about. And then I recommend that you write the variables, and I do mean list the variables. So look in your material table here and see what's unknown. So in this case, F and P are the 2 variables. The number of unknowns is found by just simply counting the variables that I listed there. So there are only 2 variables. So this is what I'm going to be looking for. And now then, I need to come up with how many equations I can have. My categories of equations, since we're not yet dealing with reactions, I have material balances, sum of x equal to 1 equations, and then those process specs. So in this particular case, I can do a material balance for every component that is identified in my table. So here I have fat and I have everything else. Now, of course, I can also do a total material balance, but that's not independent. So to know how many independent material balances I can write, I'm going to count the number of ingredients, subtopics, so fat and everything else. Okay, now sum of x equals to 1. These only count if I can write an equation that has an unknown in it, because the purpose of this degree of freedom table is to identify equations that I can use to solve for unknowns. So in this particular case, if I look at this, I know all of my x's, so therefore I have no sum of x equal to 1 equations. Now what about process specs? When you read the problem statement, there's one kind of weird thing there. It says that the optimal sweet snack will contain 15 weight percent fat. But I've already used it in my table here. Since I've already used it, that's not going to provide any additional information, so I have no additional process specs. I can only count it as a process spec if I haven't already used it in getting my table written down. So therefore, my degrees of freedom, I have 2 unknowns, 2 equations, it's 0, so this is properly specified. So if you want to write your system of equations that could be solved, I really only need 2 equations. I could do the total mass, which is feed in is 30 plus F, output is P. There's no accumulation, so that's equal to 0. Or I could say 30 plus F equals P. And then I can do a fat balance, which is 19% of 30 plus 11% of F will equal 15% of P. The third equation really can only be used as a check. Okay, so for everything else, it would be 81% of 30 plus 89% of F is equal to 85% of P. Now you could have listed any 2 of these. The third would not be unique, and it's just a mushing addition actually in this case of the two. And so therefore the third equation is dependent.